Welcome back, everyone. So we're going to look at the remaining examples. I'm not going to do all of them, but I'm going to kind of do one from each section here. So for the rewriting expressions, we can pick one of these to work on. So why don't we look at 6? So for this one, we might be tempted to try to use substitute, but we'll run into an issue of not being able to replace the, not being able to replace the 3 here. So what we're going to have to work on then is splitting this expression. So we're going to rewrite this as x over add 4 minus x squared dx plus the integral of 3 over square root of 4 minus x squared dx. And then we can evaluate each one separately. We're going to have clearly this one is going to be an arc sine. And then this one is going to require a u substitution. So let's start with that one. So for this one, we'll let u equal 4 minus x squared. So du is equal to negative 2x dx. So we get negative half du is x dx. And for this one, we can see that this is simply going to be 3 arc sine of x over 4. So that one's pretty straightforward just from that general rule. But for that first one, we should finish working that one out. So that's going to equal negative 1/2 integral of du over rad u. Again, plus 3 arc sine x over 4. Just put a plus c there, and then now we can work it out completely. So we'll have negative half. We're going to have 4 minus x squared is u. So that'll be times 2. So actually that negative half is going to disappear. So we'll just have negative 1. Excuse me, plus 3 arc sine x over 4 plus c. So again, not every example is going to be automatically an arc sine, arc cosine, arc secant. Sometimes we'll need to split the expressions and then evaluate separately using u substitution methods. For number 8 and 9, we've got completing the square. 8 looks like the easier one possibly. That's going to be an arctan. So why don't we take a look at this possibly messier one here, number 9. So again, we can try a u sub, but we'll run into an issue of having an x in our derivative expression that can't be substituted. So what we're going to want to do is complete the square inside the radical here. So let me zoom out a little bit. So we'll have the integral 2 dx over, so I'm going to factor out a negative 1, and then we've got x squared plus, minus 4x. So plus 4 is going to complete the square, but I'm really subtracting 4 because I have this negative on the outside that I need to distribute. So I'm going to add 4 on the outside. And then we can just rewrite. So the square root of 4 minus x minus 2 squared. And we can see this is a simple arc sine antiderivative. So we'll have 2 arc sine of x minus 2 over 4 plus c. So again, completing the square, another nice one that in most examples will be pretty obvious. All right, so let's round it out with our additional exercises here. So 1 looks like we've got an arc secant. So we'll let u equal x squared, it looks like. So then du is going to be 2x dx. So let's see. But we don't have an x dx, we have a dx over x. So let's see what we can do here. So we'll note that x is going to equal radical u. And then du over radical u times a half. So again, using the fact that x is the same as rad u is going to be dx. All right, so we've got quite a bit of substitution that's going to go on here. So the 1/2 I'll just put out in front, and then we'll have du over rad u. So why don't we do it this way? So du over rad u is going to replace dx. The x is just going to become rad u. And then we'll have the square root of u squared minus 4. So then clearly we can see that this rad u is going to go into the denominator with this rad u and simply become u. So we'll have the integral of du over u rad x squared minus 4. And there is our familiar arcsecant form. So we get 1/2 times 1/2 arcsecant of might help if I kept my u correctly there. So u squared, so x squared was u? Yes. So it's going to be x squared over 2 plus c, so then we just get 1/4 arcsecant x squared over 2 plus c. All right. Number 2, we've got, this is a pretty straightforward arcsine. So we've got arcsine of x over 2 evaluated from 0 to 1. So we'll have arcsine of 1/2 minus arcsine of 0, which is going to equal pi over 6 minus 0, which is just pi over 6. So 30 degrees is going to be our answer. Pi over 6 radians. For number 3, again, we've got this incomplete binomial that looks like it needs to be completed as a trinomial. So we're going to complete the square here, it looks like. So let's leave a bunch of space. So we've got x minus 1, and then we're going to have x squared minus 2x plus 1 minus 1. So this looks like it's going to be arcsecant. So we got x minus 1 squared minus 1, so that fits the form. Clearly we can see u is going to be x minus 1, but we don't really have to do a substitution because there's no chain rule that we have to worry about in terms of coefficients. So we're just going to end up with arcsecant, and 1 over a is just 1 because a is 1. So it's going to be arcsecant of x minus 1 plus c. All right, and then the last one, looks like we've got a 1 plus something squared in the denominator, so it looks like it's going to be arctan. So we'll let u equal sine squared x. Oh, sorry, sine of x, not sine squared. And du is going to be cosine x dx, which is what we needed. So we'll get some new limits of integration as well. So note these are for x. So if x is 0, u is going to be sine of 0, which is 0. And if x is pi over 2, then u is equal to sine of pi over 2, which is 1. So this is just going to become a really nice integral. 0 to 1 of du over 1 plus u squared. So we'll have arctan of u from 0 to 1. So we'll have arctan 1 minus arctan 0. Arctan of 1 is pi over 4. And arctan of 0 is 0. So our answer is just going to be pi over 4. So again, a lot of these are just going to be kind of doing substitutions with those particular forms. And then our last example, we want to find the area of the region bounded. Again, this is going to give us an arcsine, it looks like. And I think this is, let's say, 0 to 1 dx over rad 4 minus x squared dx. So we'll get arcsine, of x over 2 from 0 to 1, which is the same thing as what we got above on the previous example, I think. Arcsine x over 2, yeah. So again, same example for that function. All right, so that concludes the 7.5. So there's going to be a number of these examples showing up. So just make sure you're familiar with the forms and working through those U substitutions. So if you have questions, shoot me an email. Otherwise, until I see you next time.